Hi, welcome to Tercen. In this video we're going to learn some basic features and get started with data analysis. First, let's orient ourselves. After you've signed up for Tercen, you'll be taken to your home screen. The first thing to look at is the breadcrumb. It is a pathway from your home screen to wherever you currently are in Tercen. All the steps on the path are clickable and we use them to navigate around. Remember, if you get lost, you can always click the home button to start again. These tabs organize your home screen into projects you're working on, teams you're a member of, and the activity log. Let's go back to projects and get set up for the lesson. Click the Explore link in the top right corner. This is the section where public projects are available. Find the one called Get Started with Tercen. You will see a clone icon on many things in Tercen. This lets you know that you can copy it. Press the Clone Project button to take a copy. Give it a name. Set your project to be public or private. Public projects appear in the Explore section and can be seen by everybody. Private projects are only viewable by the person or the team that created them. Click into the Files folder. Export each of the tutorial files to your local drive. When this is done, go back to the project and delete the Files folder. Okay, now you're ready to start the tutorial. Let's take a minute to get familiar with the data before you upload it. Go to your local download folder and open the example data file in a spreadsheet. There are 127 unique patients in this experiment. Each one has multiple immunophenotype measurements. Note the header names of the columns. These will be important later when we use Tercen. Subject ID is the code that identifies an individual donor. Some columns have patient information such as age, race group and sex. Others have information on the experiment such as panel type and immunophenotyping labels in cell subset. And most importantly, the main measurement called value, which is a percentage of cells of that type in the sample population. Okay, back to Tercen. Click the New Dataset button to upload. Tercen importers are specific to a file type, for example FCS files or Excel files. Our example file is a CSV, so choose that option. You can drag and drop the file or use this button to browse to it. When Tercen uploads a file, it converts it to a dynamic table. You can recognize the original data with some tracking codes added by the importer. Dynamic tables are how Tercen can relate data and create visualizations from all kinds of normally incompatible file types. Click on the project name in the breadcrumb to navigate back. A workflow is a pipeline that does the visualizations and calculations on data. Click the New Workflow button and give it a name. This is the workflow canvas. The first thing to do is bring in the uploaded data. Click Add Step. Choose Table. Select the data table we just created. Now we can build a pipeline from the table to do the analysis. Click on it to see the local toolbar. To start building a pipeline, select Add. Choose Data Step. It'll open automatically. A data step is the main engine block of Tercen. In the left panel, you see the column names from the data file. These are called factors. In Tercen, a factor contains all of the data from that column. We make projections with the factors to submit that data for computation and visualization. Click on Value with your mouse and drag it out to the screen. Don't drop it just yet. The areas where you can drop it light up in green. In the center is the crosstab grid. The x-axis and y-axis project numbers, while the rows and columns make groupings of the projected data. Drop value on the y-axis. This central part is called a data cell. Unlike an Excel data cell, a Tercen data cell can hold multiple data points. It is displaying all of the measurements in the value column from the data file, ordering them from lowest to highest. This is important because holding multiple data points or a single data point impacts how a visualization looks or a calculation is performed. We recommend that you start every projection by dropping your primary measurement onto the y-axis. Now drag cell subset to the x-axis. You've made a simple projection. The data cell now displays the values separated by their cell type. Click on the black lines of the crosstab grid and drag them to adjust how the graph looks. Hold down Ctrl on your keyboard and scroll with your mouse wheel to zoom in and out. Let's make another projection. Press the clear button to clear the grid. The data cell will split or merge based on how you make groupings with other factors. Drag value to y-axis. Drag sex to column. The crosstab groups the data into two cells, each with their own x and y axes. Drag out age. A black line appears indicating that you can drop it above or below the existing grouping. Drop it below. Let's make row groupings too. Drag cell subset to row. Drag panel type before cell subset. Groupings in a crosstab projection work from outside to in. For columns, the topmost factor is grouped first and then subgroups in order below it. For rows, the leftmost factor is grouped first and subsequent factors working to the right. Drag subject ID to below age. Now we have a data cell for every measurement. The zones in the top bar control how data is visualized in the grid. Drag value to colors. Now higher values are trending towards red and lower values are trending towards blue. Click on the Style button. Change the style from point to heat map. You've made a heat map overview of the data. Take a moment to move the black lines and zoom in to examine the data. Try to look for immunological patterns. When you're finished, click Save and return to the workflow canvas by clicking the project breadcrumb. Your pipeline steps can be renamed in the local toolbar. Call this one Heat Map and click OK. In Tercen, data manipulation is done by an operator. Operators are computer programs written by bioinformaticians. They can be simple OR scripts to do a calculation, or they can be complex programs with their own control panels and specialized graphs. Let's use an operator to make calculations on our example data. Click the data table and add. You can filter by clicking the operator tag. Search for mean and standard deviation and select it. The operator is added to the toolbar, waiting for projection. Operators have requirements for how data is projected so that they can work properly. To discover what an operator expects, click on the version number under the operator's name. This will take you to the operator's GitHub page. Input defines the layout the operator expects in the crosstab. This one wants a number, your main measurement, on the y-axis. Output lists the names of the new factors the operator will create with the results of its calculations. It will also say what data cell groupings it's capable of calculating on. This operator calculates per cell. Other operators could calculate on rows or columns. Let's go back to Tercen. Drag value to y-axis and run the operator. You can press the result button and review the new data it has produced. It has calculated a mean and a standard deviation for all the values in the data cell. Go back to the crosstab. Be aware that when an operator runs, it locks the crosstab grid. If you want to make changes, you'll have to reset the operator and run it again. Make some groupings by dragging cell subset to row and sex to x-axis. Rerun the operator. Check the results. Now there is a mean and standard deviation calculated for all 118 cells in the crosstab. Okay, save and go back to the workflow canvas. Let's use the operator results in a new projection. Add a new data step to it. The original data has its own folder and the newly created factors appear below it. Tercen inserts a namespace before the factor name to identify which data step it came from. The Tercen AI will attempt to predict the projection you want to make, but let's clear it for now and start from fresh. Drag mean to the y-axis. Drag cell subset to x-axis. Drag cell subset to color. Change the graph style to bar. If you right-click on the graph, there are some options to change the color palette. Okay, let's save our project. Tercen has several ways to export data and visualizations. Add a new data step. Clear the grid and build a projection. Mean to y-axis, cell subset to row, sex to x-axis, and again to colors. Drag standard deviation to error bar. Change to a bar graph and click Save. Tercen has a download button to generate a PNG of the crosstab. Note it will only export what it sees on the screen. If the crosstab is longer than the bottom of your screen, those parts will not be imaged. To get more comprehensive graphs, we can use the plot operator. You can add an operator from inside a data step. Operators have settings to control what they can do. The plot operator settings allow you to customize the graph sizes and titles, and it can output different file types. When we press run, it will generate an image for every data cell. Images can be downloaded individually or batched together in a zip file. Let's save and rename this step. As you progress through your project, the workflow canvas builds up a report showing the exportable data and visualizations created by the operators. You can make data tables from your projections and export them. Make a new data step. Clear the grid and make this projection. Cell subset to row, mean to row, standard deviation to row. Building an export table is one of the rare cases where the y-axis is not used. View the Tables button to see the data being used for that projection. Go to the Rows tab and select Download. A CSV file will be created. This is a useful feature to extract simple tables out of complex input files. If a workflow design is stable, it can be promoted as a template. They can be chosen when making a new workflow. Templates are used to make analysis reproducible by others or to standardize analysis for new files. For the next lesson, we will work with some instrument files. In this case, FCS files, the standard output of a flow cytometer. Click New Dataset. Choose the FCS importer. Upload the demo FCS file zip, which we downloaded earlier. The Tercen FCS importer can read the files inside a zip folder. Upload the demo FCS annotation file CSV as well. Let's take a moment to examine the files. When doing a batch upload, Tercen will merge all the files into one data table. It creates a reference table to keep track of which file name the data came from. Let's view the file annotations. This is a simple table that tells us which file is from the control group and which is from the treatment group. It also has the file name. This will become important soon. A note to people doing flow cytometry: the Tercen uploader creates a supplementary file with any channel annotations that were in the FCS files. Tercen can connect files together if they have columns that can be matched. We call this step a join. Make a new workflow. Add the FCS table and the annotation table. Now add a join step. Click the nodes on the steps to link them. Now select Edit from the toolbar and open the join step. The factors from each table are listed side by side. Databases relay information with codes called keys. In simple terms, a key is a match made between two tables because they both contain a column that has the same data in it. There are many practical keys in a typical biology experiment. Obvious examples are patient ID or sample ID. Earlier, when we checked our files, we saw that they both contain a file name. This is the key for these two tables. Select them and run the join. Data files can be complicated and have many similar factor names, so it's possible to make a mistake picking a join. Joins don't work if they can't match data from both tables, but we can use a data step to check if the join is good. Click the join step and add a data step to it. Drag file name from the demo FCS files to row. Drag file name from the join also to row. If an incorrect key was chosen, there will be no match, and the file name that came from the join will be empty. This is an easy way to verify if the join is working. With the join, we can now make projections from all files in the same crosstab. Add a new data step. From the demo FCS files, drag the FSCA channel to the y-axis. Drag file name to the column. From the join factors, drag condition also to column. This projection enriches the FCS files with the metadata from the annotation file. An important concept for data analysis is the difference between wide data and long data. Putting it simply, wide data is the traditional table format that you would see in a spreadsheet like this one, with column headers and each row being an individual record. Wide data is easy for humans to read, but it is difficult for computers to read. Computers work faster with lists, where every measurement is an individual. Because the data you have might not match how an operator is designed, it might be necessary to convert from wide format to long format. Tercen converts wide data to long data using the gather step. This illustration shows what happens during a gather. Each measurement gets an individual row, and its column header becomes the variable used to describe it. The non-specific column headers are repeated as many times as needed on every row. Note that two new group names in purple are created. Variable for the group of channel names and value for the group of measurements. Watch out for this later. Here's how to do a gather in Tercen. Add a step to the data table. Select Gather and open it. Now select the channels we want to make into list format. Leave time ungathered. Now run the step. Add a data step to the gather. See there are two new factors, variable and value, based on our selections. Using long data gives advantages when making graphs. Since the variables are bundled together, their measurements can now be projected as a group. Drag value to the y-axis. Drag variable to row. Now there is a separate row for each channel and we can make multivariate plots. Drag SSCA to x-axis. Tercen will build a bivariate plot for each of the channels against the one you've selected. Filters are a way of narrowing down the data projected in a crosstab grid. Use them to control what is shown in a graph or sent to an operator for calculation. See there is an irrelevant comparison in our projection. SSCA is being compared to itself. Let's remove it with a filter. Drag variable and drop it to the filter zone. Change the name to Exclude Channels. Filters are a list of rules built up in the settings. Each rule has three parts: the factor it's based on, a logic for the rule to use, and a piece of data to define the rule. To remove the SSCA channel, we will build a rule as follows: variable, factor, not equals, logic, SSCA, definition. You can use the search icon to find individual data in a factor. Click OK. It's gone from a projection. You can reopen a filter here to modify it. Let's establish a range with a filter to exclude outlier values. From the gather, drag value to filter. Call this one upper and lower bound. Set the logic to value is greater than 0. Press plus to add a line. Set this one to value is less than 10,000. Be aware that filters apply their rules from the top down. The top rule is applied first, and then the next one, and so on down the list. The rules at the top do affect the rules that come after them, so it's possible for an earlier rule to exclude data that you expect a later rule to operate on. Tercen filters use Boolean logic, which is based around the concept that all values are either true or false, and by asking enough true-false questions, you can get to any data point. We will conclude the tutorial with a look at teams and link sharing. Anybody can create a team and add new members. You can add people by their username or their email account, and set permissions for them. Any projects created while inside the team will be visible to everybody in the team. Every location in Tercen has a URL reference. So if you want to go to an exact spot in a project to help a colleague collaborate, copy the URL and email it to them. Remember, they will need to be a member of your team to be able to see it. That is the end of the Getting Started tutorial. Now you should have the basic skills to navigate Tercen and start your data analysis. Feel free to go to the Learn section where you can search for help articles and tutorials, or click on the chat widget to contact us directly. Thanks for watching.